Welcome to Phases of Venus, lab number 7 for Astronomy 110. Here is an image taken from Earth of Venus in the sky and Jupiter as well. Venus is sometimes known as the morning star and an evening star, not because it's a star. Astronomy is such an old science, it is full of misnomers, and to call Venus an morning star or an evening star is just a relic of the fact that Venus is so startlingly bright. It is the third brightest object in the sky, second to the sun and the moon. So this misnomer has nothing to do with Venus being a star at all. It's just because it appears so bright from Earth due to its very reflective clouds. So actually Venus is a planet. It changes its position in the sky relative to the background stars. And like Mars and Jupiter and Saturn and Mercury, this changing in its position relative to the apparently fixed background stars is how it originally gets its name as planet. So this lab is about what we can understand about Venus and what it explains to us about our place in space, and in particular in our own solar system. So this is the culmination of our 3 labs, beginning with the retrograde motion of Mars, which reviewed what you can observe about the planet of Mars without a telescope. And it was very confusing why Mars goes retrograde in the sky until the telescope was invented, which assisted us in changing our perspective about our place in space, in particular using observations of Venus. So our lab is assuming that you can observe Venus with a telescope, and we are going to look at Venus as if we had a telescope, as if we were outside observing Venus over months. And we're going to ask, how does Venus through a telescope appear to change over time? And what would it look like in a universe centered on Earth, the geocentric universe? And what would it look like in a universe centered on the Sun, the heliocentric universe? So to begin the lab, you're encouraged to read the background material in the lab manual before you begin the 2 main procedures, procedure 1 and 2. After you read this introduction in the lab manual, you are encouraged to review the phases before recording the phases of Venus. So this video, which is the second video in the lab number 7 set of materials, titled How to Name the Phases of Venus Using the Moon's Phases as an Example. And it covers the names of the phases and what a phase is. So you're encouraged to review this, especially if you would like to review what a phase is and what the names of the phases are, before you move on to the 2 main parts of the lab, the data taking. The 2 main parts of our in-person lab are going to be replaced. The 2 parts are 1, geocentric theory, recording the phases of Venus, and part 2, the heliocentric, recording the phases for Venus again, but in the heliocentric model. These in-person activities are replaced and guided with these online materials. The first part is this link here, drawing geocentric phases of Venus, and part 2 is drawing heliocentric phases of Venus. So these 2 in-person procedures are replaced by these online procedures, which use 2 different applets to visualize a geocentric universe and what Venus looks like through a telescope in a geocentric universe, and a heliocentric applet that allows us to examine what Venus looks like through a telescope at different positions in its orbit around the Sun in the heliocentric model of the universe. After you have taken your data here in the data page for the geocentric theory in part 1 and for the heliocentric theory in part 2, or however your instructor would like you to record or use the data and the data pages, you then have some analysis to do. Going back to the lab, you'll see that after Procedure 1 and Procedure 2, there is a set of review questions to analyze this data and to try to reveal what we learn about the universe based on these two predictions in the heliocentric and the geocentric model. So the first report section question is just to list the phases that you found in part 1. The second is to list the phases that you found in part 2. This third question is showing you a set of images of Venus, and I'm going to get an improved set of images of Venus through a telescope. So these are real images of Venus showing the different phases that are revealed by using a telescope to observe Venus in real nature. So here is nature. Here are your two models, the geocentric and heliocentric, and you're tasked to answer which theory is consistent with the real data. So here is a real set of images of Venus that improves upon this older set. Then you have two more analysis questions. In particular, at what phase does the Earth appear to be in as seen from Venus during each of the phases in part 2? Now, in general, compare the phases exhibited by an inner planet to those exhibited by an outer planet in the heliocentric theory. So, in other words, what are the phases of Earth if you lived on Venus? So, what are the phases of an outer planet compared to an inner planet? And it's asking you to generalize that. One way to think about this question is to look at the applet that we used that has two planets, an inner and an outer planet, and try to imagine what this outer planet would look like from this inner planet. And you can imagine placing yourself at any position around this inner orbit, such as Venus, and try to imagine what you would see of this outer planet, Earth. Which part of Earth's illumination from the sun would you see if you looked from this position, looking here, or this position, looking here, or this position, or any other position? And another useful tool to look at this is this phase positions demonstrator, which is general for any planet. And here's an inner planet, and here's the outer planet, and this is showing you what planet 1, this one here, looks like from planet 2. And then this little graphic shows you what planet 2, the inner one, looks like from the outer planet 1. So this question is really asking about what planet 1 looks like from planet 2. So I'm going to click and drag planet 2 around its all possible positions. Doesn't really matter if it's a big or small orbit. I don't mean to be varying that as I drag it around. But basically, look here. Look at planet 1 as seen from planet 2 and judge what phase you observe planet 1 to be in at all these different positions of the inner planet. Ignore this bottom one changing. That's the other view of 1 from 2. But we want the outer planet, planet 1, as seen from planet 2. So as I change the position of the inner one, these are the full range of phases that planet 1 would exhibit as I change planet 2's location in its orbit. It's showing you all the possible phases that can be seen in planet 1, the outer planet. And then the last question is pointing out that Venus takes about 225 days to go around the sun. Yet, Venus's cycle of phases, it takes more than 225 days to go from one new phase to the next new phase, as seen from Earth. And it's asking, why is this? This applet is a useful tool to consider answering that question. So here is an inner planet such as Venus, and here is an outer planet such as Earth. And they are oriented now such that this inner planet, if it is Venus, is in the new phase. The sun's illumination is hitting this side of Venus. Earth would view this shadow side. So this is the new phase. And to consider why it takes a different amount of time to go from new phase to new phase, I will let the animation evolve for one orbit of this Venus-like planet with an orbit of about 225 days. So if I let it go around once, let's see where it ends up and why it's not another new phase as seen from Earth. So Venus is almost in the, I'll drag it back a little, almost in its original position. So it has taken one orbit around the sun. And is it in the new phase again? ... That's for you to consider why it isn't. So after you take your data, you do need to do this analysis, with the crux of the analysis being, look at what this theory predicts in the geocentric model. Look at what the phases of Venus predicted by the heliocentric theory are. They are two very different predictions. Then, looking at Venus with a telescope, what does nature tell us? And whatever nature says is more consistent with which of these theories tells you which theory you can have more confidence in. And that is the Phases of Venus lab.